and good evening. I'm Michael Pingram from the Waikato Regional Council in Hamilton, New Zealand, and been asked along today to give a bit of a Waikato snapshot of, a young scientist's perspective on river management in my domain. So a bit about me. I graduated with my PhD in 2014 in biological sciences from the University of Waikato here in Hamilton. It was largely exploring aquatic food webs and ecosystem linkages and how those responded to changing hydromorphic classifications in the lower reaches of what is New Zealand's longest river, the Waikato. And this was largely done using stable isotopes of carbon and nitrogen to trace energy flow and interactions between the lower parts of the food chain and the upper food chain. I've been at the Waikato Regional Council since 2014 as well, and before that I had a stint also at the Central Government Agency of Department of Conservation, who are also charged with looking after the native biodiversity. I was particularly interested in our aquatic fauna. So just a bit to begin about the Waikato region. So it's the fourth largest region by area in New Zealand, operating across 25,000 square kilometres approximately. The regional councils in New Zealand are responsible for resource use activities, so looking at discharges and water takes and that sort of thing is the main part. So the Waikato region extends from the Coromandel Peninsula in the north all the way down to New Zealand's largest lake, which is Lake Taupo in the south, and crosses New Zealand to touch both the west and the east coast at that part of New Zealand. It is home to about 10% of New Zealand's population and has a couple of main urban centres, the largest of which is Hamilton, where I'm based. It's also, as I sort of mentioned before, it's quite largely based around the longest river in New Zealand, which is the Waikato River, which flows from the Tongariro National Park north for around 400 kilometres to the sea just to the south of Auckland. In terms of the resources, which I'm particularly interested in the region, we have around 40,000 kilometres of mapped streams and rivers. This sort of mapping is largely based from a digital elevation model, and these cover first order streams all the way through to larger eighth order rivers. The Waikato Regional Council, where I'm employed, is basically given the job to sustainably manage the region's natural resources with the social, economic, environmental and cultural well-being of our communities in mind. So it's around sustainable development and looking to the future and how we manage some of these resources. We're responsible for implementing, but also have available to use a range of legislative frameworks laid down by central government. And these are with respect to sort of regional spatial planning, civil defence, land transport, including trains and roads, managing the activities and the effects of activities on our air, soil, coastal and water resources and environments. And we do this through a range of high-level spatial policies, rules, and also through the consenting of certain activities. And so consenting for us is where an activity such as a discharge or a land use change or any activities really to do with waterways has to get permission from the regional government, and we're responsible for granting or declining that consent based on the activities effects that it may have, and monitoring the mitigation and control of those effects. We're also responsible for the flood control and drainage schemes. So we have quite an extensive flood control network, particularly in our lowland environments. And as some of you may be aware, large parts of the region were once quite large wetland areas, and around 150 years ago, these were subject to drainage. And so we're responsible for maintaining those schemes. We also play a role in animal and plant pest control, or this is largely limited to terrestrial organisms, and there is a little bit of a grey area with regard to which government agencies are actually responsible for controlling things such as invasive fish, for which we do have a number of issues with the Waikato region being one of the hotspots for invasive fish species in New Zealand. And we also play quite a strong role in environmental education. So I guess my role within this organisation, which has quite a diverse range of responsibilities, is I'm employed as a freshwater scientist for my expertise in aquatic ecology, really. And I'm responsible for designing, analysing, and also reporting the results of our monitoring activities. So as a government agency, we're responsible for monitoring what we call the state of the environment. And so largely to do, in this case, with ecosystem health and ecological health of waterways. We have to monitor quite extensively the streams and rivers throughout the region, ranging from wadable waterways through to our larger non-wadable floodplain rivers. And we're responsible for reporting on the state and also the trend that we might be observing with regard to that health. And also we do quite a bit of research, particularly in my case on ecological matters. And this is really to try and provide new information and new understanding, which can feed into, I guess, improved environmental management or improved restoration activities and new policies and plans that might be required by central government legislation. So as part of that, I've done quite a bit of work utilising our monitoring data to identify key environmental stresses and thresholds for our wadable streams in particular. And this is largely based around the macroinvertebrate and communities and also some assessments of in-stream habitat. As part of this, I take quite a lot of work collaborating with other research organisations and bringing some of that knowledge into the organisation, but also supporting those agencies with their funding bids in both a technical and also a support role to help them create new knowledge and tools and understanding that might be of assistance to regional council going forward. And then I'm also involved in some river restoration activities, sort of helping to design and assess the effectiveness of these projects, and then also reviewing whether certain activities, the effects can actually be managed or whether they need to take some alternative approaches to what the outcomes of those might be. Some of the work that we've done quite extensively in the Waikato has been around developing new indicators for non-wadable rivers, as we have some of the largest rivers in the country. So we've explored organic matter breakdown rates, which is just the example here on the slide. So we've been looking at using standardized cotton strips and looking at the rate at which they break down in certain waterways. And in general, we do find quite a strong relationship between these rates of organic matter decomposition by microbes and fungi and the nutrient concentrations which some of these larger waterways are essentially subject to over large parts of the year. So in the Waikato region, we have a number of river management challenges. One of the most topical ones is really the water quality of these rivers. And particularly in terms of my interest with regard to some of the quite important ecological parameters, such as fine suspended sediment, which we usually monitor largely through black disk or clarity measurements, and these are generally related to high suspended sediment loads in these rivers. And as you can sort of see on the map, we have a number of sites in red which are actually below what would be considered the national bottom line or a poor condition for rivers nationally, and some of them are actually getting worse through time. And in the photo here, we just have an example of the Waipa River, the largest tributary to the Waikato, and this is in flood flows, and just demonstrating that some of our rivers disproportionately contribute fine deposited sediment and fine suspended sediment to their receiving rivers. And this is just quite a nice picture which just shows it nicely. The Waikato River and also the neighbouring Piako and Waiho rivers have quite extensive modified floodplains, and these are protected and essentially maintained through a series of quite extensive flood schemes. So we have some quite modified floodplain areas, and these are basically maintained through flood pumps and floodgates, and these have their effects on native biodiversity, or either fish being essentially killed as they pass through flood pumps or being restricted in their ability to access upstream habitats. So these areas cover quite a large part of the lower large rivers. We also have, as I sort of mentioned before, a number of challenges related to invasive species. So aside from a number of plant species, which those of you in Europe will probably be quite familiar with, we also have a number of fish species which have taken hold and established quite extensively in these river basins. The most problematic of these is the koi carp strain of common carp, and these grow to huge abundances in our lower rivers. And associated with this is ongoing, I guess, native biodiversity loss, which is occurring both as a result of changing land use, but also as due to competition with introduced fish species. And one of the interesting challenges that we do face in our region at the moment is the rapid rate of urban expansion, which we see. And we see this is a mudfish here in the lower picture, and these guys can estivate or essentially hibernate when water levels drop out of the system. And these guys are quite threatened by the development of flat areas with drainage channels, which is what they like to live in. So we've got a number of biodiversity issues as well. And then all of these river management challenges are further complicated by our expectations for ongoing climate change with increasing flood pulses, potentially some longer summers, and we've just come out of a series of quite lengthy droughts in our region. So we're looking to manage the ongoing effects of climate change and what that means for these other challenges as well. So obviously there are a number of obstacles and levers which we can look into. I think probably the largest long-scale lever, and probably presents itself as somewhat as the obstacle as well, is our need to sort of come up with some spatially and temporally strategic trade-offs and balances, and how we might strike those between competing needs and requirements. Whether certain areas are actually tenable to still defend into the future in the face of climate change, but also whether certain floodplain areas might need to be reinstated in the future in order to provide water quality benefits, but also ecological benefits for native fish in particular, and meeting some of their spawning requirements. I guess also that managers will need to be aware, and hopefully they are aware, that many of the restoration actions we have, or some of the tweaks and levers that we can pull, will have quite long lag times before we start to see a measurable improvement that can actually be realised through our restoration activities. And I guess a nice example that we have is that some of our water quality attributes, particularly to do with dissolved nutrients, we're still seeing nutrients come into the mainstem rivers passing through groundwater that can be decades old. So we've still got a long way to go, and some of these responses could be quite slow, even if the management interventions are quite quick. But there are a number of short-term levers that are available, and some of these have got some really good promise in that they are reasonably small levers to pull, but there are a lot of them. We have a lot to choose from, because they are just so widespread that we could actually start fixing a few things. So I guess some of the levers, particularly in lowland environments, which I guess is where we see a lot of our challenges, and will be a number of our challenges going forward. I think restoring fish passage. So the majority of native fish in the Waikato region actually have a migratory phase. So they need access to both lowland estuarine or coastal environments and to freshwater headwaters in order to complete their life cycle. So really, by installing fish-friendlier flood pumps and gates, we can try and allow these species to move from lowland environments to upland environments, and also into lateral habitats, such as wetlands and lakes, for which we have lost a degree of connectivity as well. So by installing some more fish-friendly infrastructure, we can potentially open up habitats which have been disconnected for a number of years. Culverts are a particular challenge that we have. So despite a lot of our fish being pretty good climbers, they can't climb a perched culvert where there's basically nothing for them to climb, where the culverts have basically eaten away the earth beneath them, and now it's essentially an airdrop down to the river. However, we've been playing around, and some of it was sort of trialled quite extensively in our region by my colleague Bruno David, by installing sort of plastic muscle spat ropes into these culverts, and this allows some of our better climbers to actually use the small spaces in between the plastic strands to utilise the running water to actually climb their way back up and through these quite steep culverts. So there's some real promise there for certain types of streams and certain size streams. And also I think restoring some lateral floodplain connectivity and access to some of these floodplain habitats such as wetlands and sidearms, and certainly reinstating some of the connections will go a long way to increasing the habitat available for our native species. One of the challenges we do face is that restoring this connectivity, particularly in lowland environments, is that we also have a range of invasive species that would love to take advantage of this restored connectivity. In particular, koi carp, which you can see in the top photo there. And so these guys basically have been bottlenecked at a grill that's been placed at the outflow to one of our key lakes. So this fish above a certain size can't make it through the grill, but they can exit the lake. So the goal with this particular example was to try and remove them from the main lake itself and then try and prevent re-entry in an effort to restore water quality. And also, I guess with the culvert example and the spat rope and the lower photo there, most of the introduced species we have wouldn't be able to climb even this restored fish passage. So it excludes those from the system above. But we have, once again, my colleague Bruno has been busy coming up with ways to manage some of these invasive species, and we've had quite success in managing containing these species by particularly koi carp, by exploiting parts of their life cycle where they like to move into floodplain lakes or wetlands, either to spawn or to get on top of some seasonally abundant resources. So in this example here, Bruno was essentially diverting water around a floodgate. The fish were attracted into this artificial stream. They were then caught in a cage, which interestingly allowed most other species to get through, particularly native eels and bullies. And these carp were then euthanized and placed in a microbial digester. And eventually the final product is a series of fertilizer pellets. And the interesting thing here for what Bruno achieved is that these pellets were able to then be recycled into other restoration activities in nutrient poor areas, which such as dune replanting. So a nice sort of cycle of turning something potentially quite bad into something quite good. What we have however, in New Zealand and particularly in the Waikato, there's actually a lot of really encouraging policy direction. And coming out of one of the most high-profile treaty settlements we have was Te Ture Whaimana o Te Awa o Waikato, and this is the Waikato River Vision and Strategy, and this is helps us to go into setting a policy direction which is essentially linked closely to Indigenous Maori values and co-management principles. So the vision and strategy has become the primary direction-setting document for the Waikato River and its catchments, and this actually sits at a higher level than most national planning documents. And the overarching purpose of this is to essentially restore and protect. So rather than having a system where a little bit of effect is allowed by certain activities, the goal for these activities when they're being reconsented or policies being rewritten is actually to have an improvement in the health and well-being of these catchments. This has sort of been echoed then further in national policy with Te Mana o Te Wai concept in the recent National Policy Statement for Freshwater Management in 2020. And Te Mana o Te Wai essentially refers to the fundamental importance of water and recognises that protecting the health of fresh water protects the health and well-being of the wider environment and also the communities that rely on that water. So it's about restoring and preserving the balance between water, the wider environment, and communities' needs, including economic needs. So I guess my recommendations, I guess, for going forward and some of the challenges is to really look for complementary measures, particularly starting with some enhanced catchment management. So trying to reduce some of the upstream contaminant loads, such as sediment and nutrients entering these systems. So what can we do to better manage the land, particularly in New Zealand, where a lot of our catchments are very steep and they have quite young soils. So what can we do to better manage the land itself so that we don't see these challenges, particularly to do with water quality manifesting in the water bodies themselves? But also looking to strategically modify floodplain infrastructure. Where are some areas where we could either retire land or where it may not be economically viable to protect some land in the future? Where can we create, I guess, floodplain connections that might enable some processing of sediment or nutrients as part of the floodplain cycle, but also open up habitat, particularly spawning habitat for our lowland fish species. And this then feeds into restoring habitat, particularly spawning habitat for our native fish. So a number of our key lowland species require terrestrial riparian vegetation to spawn upon, and they time their spawning and larval release with big spring tides. And so how do we restore some of that spawning habitat or adult habitat in other parts of the floodplain for those species? And then targeted management of invasive species. In many cases, we will struggle to eradicate these species, but how can we exploit them, as Bruno's pilot study showed, and potentially reduce their biomass in a way which we might see some positive benefits, or reduce the competition for key native species. And I think key to our success going forward will be largely reliant on how we rethink floodplain and drainage management to include ecosystem values and ecosystem services. Essentially, how do we make how we manage our floodplain systems? How do we make the ecology and the fauna and the biodiversity one of the goals of that system, as opposed to as it is now, where the main focus is on maintaining agricultural land for production, which is a fine goal to have. But how do we add in this other layer and strategically manage that floodplain for better outcomes for a wider community? And I guess building into this as well is how do we allow and adapt to climate change in response to a number of the droughts that we've had in recent years. We've also had these followed by large blackwater events. So how do we manage our infrastructure and the ponding of water behind some of this infrastructure so that these don't occur or aren't as severe? And this is going to require ongoing, long-term, but also extensive commitment and cooperation and co-management between everyone involved, be they regional councils, central government, industry groups and local communities. And this will quite clearly have to follow quite a strong lead from our treaty partners and be a real co-management, joint management approach with iwi. I think that's me. Thank you very much.